in such a position. It's no surprise to me, Andy is the individual that I sent to ARTS to get myself off the hook for all the things that I had created as obligations for. The company always believed in the standards for big reasons, and Andy's one of those characters who will jump in far beyond his personal interests, far beyond his areas of expertise that are useful and commercial at this point in his life, because he just cares deeply about the work itself. Today talking about everything location. If you would please help me welcome Andy Mattice with Lexmark.
Let's see, I'll get this loaded up.
Can everybody hear me okay?
Yep.
A little too loud, a little too not? All right, Mike? Okay. Today we're going to be talking about location-based technologies that are used and applied in retail, the standards that help us adopt these things, a little bit of a talk about the standards themselves, what types of hardware are coming on the market that you'll be able to see, how different industries overlap in this regard. We'll just jump right in. So first about me and about Lexmark. Lexmark is the former manufacturing center for the IBM Selectric typewriter. There's an interesting story to quickly start that off. One of the first key loggers of a hack was found when, let's see, 1976 they were installed, Selectric typewriter 2 and typewriter 3s in the Leningrad, U.S. what is it called, embassy in Leningrad and also in Moscow. And it was 12 years later that they were first serviced. They did not have to have any service between those, that entire 12 years, and it was for them to be oiled, interestingly enough. And when the technician opened up one of those typewriters to oil it, they found that there was a device inside that was measuring the magnetic induction of the assembly that performs the typewriter function, and was storing that information and then sending it out, beaconing it out at periodic intervals. The 12 years that those devices ran, that type of mantra still exists today at Lexmark. So we'll move on quickly here. I'll just have a little bit of a spiel. We'll make it fun. We make printers. People love the printers that we make. We moved into doing other things like robotics, and I'll get into a little bit about how that ties into location. We started making robotic platforms. We separated this off, became a different company. You can see here it looks a lot like a printer on wheels. I love that our robot looks exactly like a printer. Has cameras, figures out its own environment. We did this as a way to experiment with a lot of what we do and the capability we have. A very interesting part of it, I think, is the wheel that you see in the bottom there. That's a piece of intellectual property that Lexmark carried on. When we had to make our own robotic platform, we reinvented the wheel. Right? I love that. It's a lot of fun. Now, the company that's taken that on is Badger Technologies. They're there near the headquarters where we were in Lexington, Kentucky. This is Marty. A very interesting thing early on was the difficulty that, the behavior that it imposed on the people that interacted with the robot inside the store. When you see a big silver aluminum monolith coming towards you in the aisle, people tend to be a little bit afraid. Adding googly eyes really does the trick. It's no longer looking at you, it's looking at the shelf. People see what it does. Kind of doesn't really go in a straight line anymore, so people feel a little bit sorry for it, like it's kind of sick. I think that was very interesting. It makes people feel like, oh, the poor robot. They'll push things out of its way instead of ram into it with a shopping cart. It's those little things that really make the difference for a solution. We do all kinds of other stuff. So primarily, like what Dean was talking about, the division that I work in is about shelf edge rendering and marketing messages that are passed to a consumer about the products that are in a store. So I work on, for Lexmark, it's about printing those, producing them on Lexmark printers, but it's also outputs that go to digital formats of all sorts, digital color displays, electronic shelf labels. And this is an example from a test bed that we set up for a robot to learn about environments. So with all of these solutions, this chart that's from our sales brochure. What we've learned is a lot of systems that come on board that are a particular point solution for finding location, finding something about a consumer, understanding something about a product. By themselves, they never solve the business problem that's put in front of them. So a retailer will have an actual business case that these things need to be applied to. And to do that, it's very dirty, right? It's never as clean as the original idea is, and it's about integrating with all the different types of systems to make a solution a reality. And a retailer who can't buy everything all at once needs to impose them in different periods of time. And this is where the standards become very valuable. So, a little bit about me. This is a vehicle that some of you have heard about. It ended its life somewhere over Delta Dock at the Bangor nuclear missile facility. We won't talk about how it got there or what happened before or after, but I'm here in front of you all, so it turned out okay. This is the current rendition of that. So I've used some of the location technologies that we're going to be talking about here. I actually forget which specific one, but an ultrasonic location technology. This is an autonomous vehicle that understands where it's going to fly, maps the area that it's flying in. It's a test bed to try to get people interested in working on these types of problems. You're never going to see this vehicle flying through the aisles of a Walmart trying to scan the shelves, banking those corners, but you will see the stuff that's coming from Badger Technologies doing that. This is another example of how this stuff grows out, and we'll be done with this very soon. This is a project from Boeing. So in the club for robotics that I belong to, some of the other groups for autonomous flight vehicles, some of the other people are Boeing engineers. My particular project is to try to get a vehicle to fly up to 40,000 feet. That's just a smidgen above the 400-foot limit that's allowed by law, but we'll deal with that when we come to it. This one at Boeing, it's twice the width now of a 747, flies at 90,000 feet, acts as a constellation of low Earth satellites that's able to stay aloft for up to 9 months, solar powered as it's flying up there because it's always above the clouds. Comes back down for resupply, tooling, oiling. And back to what I do. It's about printers. It's about people who love our printers. So that's enough of my spiel. Let's see, what are we at OMG and the Inheritance from Arts? We're a community dedicated to helping retailers and solution providers identify, adopt, and integrate current and emerging information technology. We do this through assets like Unified POS, and I'll just go quickly over this because I think Bart's going to talk about it as well. Unified POS is an integration standard for devices in point of sale to talk to each other, so that's scales, point of sale systems, receipt printers, all that kind of stuff, tax calculation, how those pieces interact so that when a new technology comes on board, a retailer can quickly adopt it. And when a vendor wants to create some piece that's going to inject in it, they have the ability to do that. They have the ability to differentiate how they do that one piece, but live in the particular larger ecosystem that exists in a retail environment. Data models for how those assets can the information can be kept track of. XML schemas for the interaction of applications. Business process models represent how a retailer chooses to do business so they can focus on their strategy, and then we connect it back to the technologies that are underlying. Standardized RFPs are a nice way for a retailer to understand how to purchase a new technology that comes on board. So we help retailers and vendors combined understand how to purchase a new type of technology, like cloud offering or mobile or whatever it may be, robotics, that sort of thing, so that they know how to ask the questions about what it is, not miss key opportunities that come up from it. We'll just jump past it. Today, we're going to be talking about location. This is a little bit of a difficult chart to look at, but those spokes around the edges are, well, first of all, when you think about location, a lot of people think, oh, what's so difficult about location? Why do we need to have a standard? Doesn't it just X, Y, Z? Is it latitude and longitude? Hasn't Google and Apple figured that out? And the answer is yes, they've figured it out very well, but they haven't figured it out for all of these use cases that are around the edges of this wheel, which I can't really see on the screen here. Replenishment, video analytics, digital signage, price optimization, all of these get impacted by the location of the items and the people and the things that are involved with them. And in each case, that location can be represented in a different way. But really what we were focusing on is how to take the existing standards that we have and add location components to each of them in a way that's nicely represented to capture them and analyze them. So if we go to version 1 of the location-based apps, version 1 of the location standard, it starts with location-based applications. That was what we were focused on for the version 1 of the standard. That would be location in terms of the store, where an item is located on the floor, the department, all of that, those things. Then it moved on to detailed item information. So that's specifically the unit size and how that fits within an environment on a shelf. And that brings us to unit inventory of how those items are put together on a shelf and located next to each other. And that moves us on to item placement within a set of fixtures, which builds into the idea of a planogram. Basically, it's linear displays on shelves for planogram layouts of products, and then the effective dates and the planogram information for when layout changes are needed. Not directly an entire XYZ coordinate system for everything, although it does define that. Now, as fun as it is, I love showing XML on a presentation. Everybody's going to love this. This is an example of how this actually, the rubber meets the road. So when we're talking about a location standard, what does that really mean? And it's about the augmentation of messages that we have for systems passing messages inside of a retail environment. On the left, I'm trying to find a label printer that the labels that someone is going to reaffix to a shelf are going to find it at, and so that I can direct the output to that printer, and they can pick it up and stick it on a shelf. Pretty simple use case. On the right is the response from the store system telling me where that is located, information about that device, so I can render the output properly and send it to it. The augmentation here from what we had before was the location component. Version 2, which we did a few years later, extended the idea to have planograms and the idea of wayfinding. I'm started here, I need to get to another point. Wayfinding is relatively well defined for how to get from point A to point B and have Apple Maps give me direction, but there can be influences like whether I have a cart, whether I don't have a cart. Those can lead to different directions through an environment. So we talk about product positions, how they're faced, how an item is, if it's shown to its left, to its front, to its right, to whether the bottom of the product is showing, what kind of an inventory model the store is following, if they replace products on the shelf in a case, if they individually pick up products and put them back on, and that brings us to replenishment. Promotional marketing materials were things that were added to the location technology standards for how a product, when it gets marketed, and if a poster is going to hang, or if a sign is going to show on the shelf, or an electronic shelf label is going to be updated, how those interface. Globalization is another one that comes up. The unit of measure, whether it's dollars, whether it's euro, the languages that the promotions should be in, the tax codes that are going to be hit. Support for planograms was brought in to a more detailed level in this version 2 of standard, which ties tightly to RFID and smart fixtures that measure what's on their own shelves. And of course we talked about paths, obstructions, finding alternate paths from one point in the store to another, whether that's supply or a robot that's doing it, or directing a person to find where they need to go. Picking and sorting then fall out of that. When an order needs to be replenished from associates in the store, this is something that happens in a lot now. I don't know if any of you have seen it. The Alibaba purchased a retailer in China, a brick and mortar retailer. I think it's 120 stores. It's some name like Honey Market, 20-something, Long Market, can't remember. But it's about half the people in the store at any one time are associates that are picking up items and putting them into bags for mobile orders. And then they do it so much, in fact, that they have stations throughout the store where they'll put their bag on the assembly line thing, it's like pulls it through the sky, and then they scan the barcode on it, they scan the barcode on the shelf to know which, or on the assembly to know which one it is. That bag, along with another 100 bags, goes up over the ceiling out to be delivered by someone on a bicycle to where it's going to go. It's crazy business they have going. Now, if we talk about how this looks then, what you're looking at is a shelf. Individual shelves can have separations for the placements of the products. That shelf has a 0, point. This is kind of similar to 3D modeling from three-dimensional games, if you think of that kind of a thing. The shelf, an item is placed on a shelf. It's not known necessarily exactly where in the store every item is to an XYZ detail. Usually, shelves are laid out like a planogram, which is, horizontally along the shelf where the products show and what their facings are going to be. But then that assembly of a shelf is put on a fixture. That fixture is mounted on the floor. And so this is a system for all of those to be nested within each other, that the shelf is a child, the assembly that it's hanging on the fixture is the parent. And then further, the next parent is the bay that it's mounted on. The next parent is the store that it's in. From any one point, you can find exactly where the other items are associated, but you don't have to deal with the complexity of all of that. So if we look at that in another way, you're seeing a planogram that gets planned out by a tool like JDA's Space Manager to lay out how products are going to be positioned on a shelf, and then this ties it to exactly where in the store it's located. Now let's talk about the types of location that can be tracked, because this influences greatly the accuracy that's needed, as well as the cost of the type of technology that would solve it. So presence is just simply, I care about location, but I only care that it's here. I only care that it's in this room. I don't know where it is, it doesn't matter to me, just that it's in this room is enough. That doesn't help me when I've lost my keys and I know they're somewhere in the kitchen, but that's one. Proximity, how close is it to me? How close is it to another object? How close are these two objects to each other? Gating, you can imagine a shipping and receiving dock. When an item goes through the shipping and receiving, you want to know that it has arrived. You are going to start paying taxes on it now in a different way because it's in your back room. That can be included with direction as well. So direction is, in some cases, gating, you only care that it passed through. You don't really care about which direction it went because you know where it came from and where it's going to. But sometimes direction is important. Was it leaving the store or was it entering the store? For loss prevention, it just matters that it passed through the gate. For receiving, direction is that it went out onto the floor for sale. Fixture, what fixture is this located on? It may be that the item has a tag of some sort that's interacting with a sensor that's on the shelf. I just want to know that it's on the shelf. I don't actually care where in the store it's physically located. XY, plan view, the horizontal view of the floor plan. Where in my store is it located that way? XYZ, of course, is it up, is it below? Those types of things. We're getting just deeper and deeper into complexity of those as we go from one to the next. If we look at infrastructure, the types of technologies employed, so you may have heard of beacons, Bluetooth beacons, tags, RFID tags, access points, Wi-Fi access points, phones, consumers' phones. Phones is an interesting one. When a retailer like Target, I think it's only 10% of their consumers maybe don't have a way to purchase digitally and don't have a mobile phone. It creates a problem when some of the plans are to promote marketing events to consumers only through their phones, and then they lose a very large portion of their customer base with that idea. Lighting is another way to do it. Intelligent lights that are in fact adjusting a little bit the frequency that or the colors that they're using, and that can be a source for communication and also location. Video is one that I've used before, and we actually use the standard for that, the video analytics standard, to understand from a picture that's being captured from an autonomous vehicle, what is it looking at, and then begin building up a map of its own so that it knows the locations of everything that it sees. Barcodes is a simple one. It ties in closely with video analytics. If there's a barcode on the shelf, somebody can physically scan it and then say what aisle they're in, or a vehicle of some sort can find it and map it. User input is an easy one as well. Location doesn't need to be solved all the time by a technology that actually measures what it is. It can be a store associate picking what they're doing, or it can be a consumer walking up to one of the Kmart buttons and pressing, I want help, and someone comes to that flashing light that's right above them. Sensors are another way to pick up. There's a company that does tiles that get put on the floor, and when somebody walks over them and steps on them, they pick up that at that location there was a consumer right at that moment. That's a very cheap way to figure out the heuristics of lines at cash registers. And of course GPS for the outside, but that carries on into a lot of cost. Can't be seen inside. So accuracies and applications, this is where we get to where these things really meet. Has a product arrived at my store? Has the product left the stock room and gone out onto the sale floor so that it can be made available for sale? All those are very simple use cases. But when we talk about the technologies in a moment, and we look at an accuracy of 5 meters versus 2 meters, 5 meters means I don't actually know which aisle that item or that person is standing in. 2 meters, I do have that clarity. So, a small difference like that may seem like it's not important, but once you go below that resolution that's necessary, that becomes very important. 20 centimeters versus 2 centimeters, that's quite a bit too. When you go to 2 centimeters, you get impacted by quite a bit more cost, battery life, consumable price goes up for the equipment that gets used. Is 20 centimeters good enough? In some cases, it is. 2 centimeters gets very, very close, but oftentimes that's not really needed. Signals of opportunity. There are a lot of environments that are producing all sorts of RF, radio frequency, in a store. And some of the solutions that we'll talk about use that. They use existing Wi-Fi, they use existing other technologies there to try to augment the accuracy of their systems. So it's all about expectation management of what's trying to be solved and what's the resolution of accuracy. So let's talk about some technology vendors. Where we'll start, Impinj. Impinj has really come up to be one of the dominant providers because they've really figured out a nice way to apply their technology. And that is, they've decided to focus on a platform. So although they are an RFID company, they're really a location platform technology. They provide retailers and all types of other industries with solutions to their problems, not with a technology that just provides location. So in many cases, nobody actually cares about the exact location of this item and where it is in the store. They want to see rolled up analytics about all of that and understand how one store is performing compared to another. Impinj does a very good job of that, and we'll explore some other use cases in a moment. Blue Lock up on the top there, they make a product called UBI. They're based in the Netherlands. If you're in Europe and you go to a Delhaize, you'll most likely see a Blue Lock device mounted to the shopping cart. And what they use that for is to track where people are going inside of their store with the shopping carts without having to track their phone, without giving them another device. And they also put a button on it so that when someone's walking through the store at any point when they need help, they can press the button on the shopping cart and somebody will run over and provide them with assistance. So it's provides a nice little thing all by itself. Decawave is out of Ireland. We'll talk about them. They're a manufacturer, so there's all kinds of different levels of companies that provide location technology. Decawave does ultra-wideband radar, and they build it into an individual chip. So they want other people to provide the solutions and the equipment that use their chip. Ultra-wideband has the opportunity to be a very high resolution and cheap way to measure location. And that's because it relies on time of flight. Now, there's different ways to measure distances from radios. Some of them are receive signal strength. Receive signal strength means that transmitter transmitted and the signal is dropping off the cube root at the distance as it comes to me. So by the time it gets to me, I can calculate about how far away it is because I only sensed 10% of the energy, so I'm so far away. But there's a lot of chance of interference from that, from reflections, things like that. Time of flight is the broadcast began and it has a time code as a part of its transmission. I know when I received it. I can figure out how far it is because of the difference between the time code. That's kind of like what GPS does. The difficulty there is those signals are flying at the speed of light, so it's getting high resolution is a problem. Gips Tech in Italy, they do what we would call a sensor fusion, where they take the inertial measurement off of a phone, they take the geomagnetic magnetic location direction off of the phone. They also read in GPS where it's available, and they take like a spot location of where you are on GPS, and then when you lose GPS, start working off of inertial reference, and geomagnetic is objects in the area that they know that it's going to point to versus what the phone looks like it's turning. They can get about 1.5 meters accuracy. It's an interesting way to think about this, that there's not one technology that does it, and it's really about fusing multiple into it. Coupa is another one to keep track of. They use Bluetooth, that's similar to the Bluetooth low energy beacons that I'm sure everybody's heard about already. But they do angle of arrival. So they can get about 10 centimeters accuracy with what's basically a very, very cheap sub, maybe 15 cents, 20 cents Bluetooth tag in volume. What it does is the antennas that are on the device, either the mobile device or the tracking sensors that are up in the ceiling, they have antennas pointed in different directions. And so they'll find exactly what direction that signal was coming in at. And so using that and then fusing the others of received signal strength and time of flight, they can figure out, not only do I know how far away from it I am, but I also know what angle I'm at. So I know I'm down here instead of up here, and then triangulate further with more signals that are coming in. So if we look at, let's see, Indoors is out of Austria. Their customers are Amtrak, KLM, San Francisco Airport. Their technology runs in a phone, so it's about a program running on the phone, and it works as an offline map. So when the consumer is using the person that's having to track anything, when they're walking through an area and they've lost GPS, it can flip over to their version of a map and begin helping the user figure out where they are in some way for where the application is. Lambda 4 is out of Hamburg, Germany. They started as an avalanche discovery device. So theirs is, your devices can be tracked by a handheld unit, so you don't need an infrastructure. Their installation into an environment is a matter of hours. They just need to go through and do a quick survey. Nothing actually has to get installed in the environment. The tags are tracked by handheld devices that can find them and locate them. MarvelMind is a different way to do it. MarvelMind is interesting. They're out of Sunnyvale, California, and I've used their stuff on some of my drones. They focus more on robotics location. They have extremely good accuracy, down to about 2 centimeters. And the way they do it, instead of using radio or lights, they use ultrasonic. So ultrasonic is sound, just up above our range of hearing. And it moves through air much slower than radio waves. So because it moves so slowly through air, you can get a lot better accuracy because it's moving a lot slower. So you have a lot more time to figure out. The accuracy gets much smaller, down to about 2 centimeters. The difficulty is it has about a 16 hertz update rate. So what that means is a single unit can get 16 measurements per second. If you have 2 things that need to be measured, that's 8 times per second. If you have 16 things in the environment that need to be tracking their location, it's once per second because it needs to talk all of them. Only 16 times per second can it talk to any one to find out a location. But in most cases, nobody cares to have any location tracked down to the per second level. It's usually, for a retailer, it's more about twice a day, once a day, 5 times a day, if we're talking about item level inventory. So, we'll move on. Now we'll talk about the big ones in the room. Apple and Google. Well, most of the vendors that you saw there, they are wanting to be acquired by Apple or Google to augment technologies that they build into the next generation phones. The difference here, and there's a big difference between the way that the two of them look for acquisitions and make their choices about what's going to be implemented in the next generation phone. Apple focuses on what's known as SLAM technologies. That's simultaneous localization and mapping. So that means that the phone is able to go into an area and begin learning about its location and also mapping where it is in that location at the same time. So it's kind of a chicken and egg problem of how do you move into an environment you know nothing about, start sensing it, building a map, show the position that you're at, and then continue changing it as things change inside of that environment. Google, on the other hand, focuses on acquisitions that are about learning how to use existing radio devices in an area to augment location accuracy. And the reason behind these two different views of how they buy their technology is where those two companies come from. So Apple really is focused on getting more consumers to take their devices, to buy their devices, to buy applications so that they can get application licensing dollars, the money from the wireless vendors, and sell more of their devices into licensing dollars that are accumulating. Google, on the other hand, is focused on learning about you, the consumer, and how you can be marketed to, and how you make your purchasing decisions, how you decide to live your life, so that that information about you can be monetized. So in one case, the product is in the hand is your product. In the other case, you, the person carrying it, are the product. And that comes out differently in how they even do the tracking of that. So if we go back and look at the SLAM technology, it was a funny thing. We had to figure out how to do SLAM technology with the robot that we were working at. And, this part, this up, so if I can figure out how to get it to change. There, all you have to do is that. That's the Bayes algorithm, Bayes theorem for figuring out, I don't know what it is that I'm looking at, but I have to know what it is so that I can know what I'm looking at, so that I can then figure out what I'm looking at all at the same time, predicting the future of what you don't know. Anyway, I will save you all from an explanation about that, and I think I'm running out of time. Oh, sure, okay, we'll make this quick. So, RFID. RFID is really the technology that has won the world for location tracking, and there are a lot of reasons for that. If we look at individual tags, like the Monza tag that's made by Impinj, it's down to the level of size of 0.4 millimeters, so less than half of a millimeter. A grain of sand, for instance, is 2 millimeters, starts at 2 millimeters. So if you're less than 2 millimeters, you're not even a grain of sand, you're a powder. The individual chips, the RFID chips that Impinj makes, they're a powder. You could inhale them by accident if you didn't know what you were doing. As funny as that sounds, you could walk around with a bunch of RFID chips embedded in your lungs by accident. Let's not think about that. But, yeah, the biggest part about an RFID chip, if you look at that on the side, is the antenna. So of course that antenna is not the size of a grain of sand. But the little tiny dot that's in the middle, that is the chip that Impinj makes, and that solves all the problems that they solve for tracking our bags through the airport and everything else under the sun. Let's see, so getting that down to that size really makes a difference. It brings down the price. Let's move on from that. Added cost. This is something to evaluate every time that a location tracking technology is coming along. It's no longer about how much does the equipment cost, because of the global manufacturing of electronics now, that can just always be driven down to the minimum price of manufacturing. But where it comes to is how much is the consumable going to cost? It is constantly having to be used inside the store. For one of the parts of the business that I work in, which is retail shelf edge signage, that comes out to the paper label, how many paper labels need to be produced, how much toner needs to get used. For this, it's how many of these devices would be needed to solve a particular problem. And if we look at 5,000 items weekly being updated in 2,000 stores, at the absolute bottom minimum price for a high volume, at 3 cents added per tag times 52 weeks, $1.5 million for the year over the cost of paper printed signs. So it's coming up with, does that achieve a solution to the problems that are had? Does it save more money in downstream resources by adding this to the business? Impinj so far has produced, a little bit earlier this year, 25 billion tags globally. We in the signage business like to, oh, that's good for them. They're entering it, because we produce quite a few more signs than that all the time. But it's good. They don't get on the block. Oh, let's see. I missed one there that we'll get to. So the different kinds of tag types that are encountered with RFID. Active tags are battery powered. There's two types of them. One is transponder. That means they have a range of about 100 meters. Transponder means it's listening, or it's not really listening. When it receives a transmission, that powers up the circuit, and then it begins using the battery to transmit back. So it uses electrical power to transmit back that comes from a battery. Beaconing is it's just periodically beaconing out. It's not waiting to be told to wake up. It's just every second, every minute, it's putting out a signal. That means that it requires a battery. That battery goes dead all the time. It's an environmental impact and a cost impact. Passive is the RFID tag that most of you are probably aware of. That is that it does not have a battery. It uses some of the converted electrical power from the radio signal that comes to it to power up its circuit and then answer back. And it's on the order of like 1,000th of the receive signal strength, but it's okay because it works. Battery assist passive is another type where it has a little micro miniature battery in it. It's still all passive in the way that it receives the signal and then it uses that energy to transmit back, but it actually uses a battery to power up the chip that's inside of it, not to do the transmission. We're almost down to 1 minute, we'll cut this quick. What Impinj does, store optimization analytics. So this is about seamless shopping experience, understanding inventory availability, improving store operations, collecting analytics about the store so that the retailer can make informed business decisions. If we look at an example, La Chapelle, I think I'm pronouncing that right, they're a retailer, a fashion retailer in China. They have about 9,000 stores. It's quite a bit. They employ 40,000 people. They've grown so fast that they've felt in a lot of pain with supplying all those stores that have been coming online. So they have a vast production and distribution network. Human error during inspection, inventory processing. They have problems with stock shortages, delayed deliveries. Their labor costs were just running away. They were all about growth without figuring out how to do it in a way that was supportable. So Tsindico IoT came in to help them streamline their supply chain works. So Impinj's RFID tags were applied to each and every individual item in their inventory. Every item from the point of manufacture, has an RFID tag added to their labels to all of the 9,000 stores. They track the location from the manufacturing plant to the warehouse to the retail store to get active inventory so they're not having stockouts. The store fitting rooms identify what the selections are for the consumer that walked in with that same tag. They then offer related products to people in the fitting rooms with smart fitting room touchscreens. They achieved 3 to 5 times efficiency in their receiving, forwarding, and inventory process from the warehouse to the stores. Their inventory needs were reduced, so they didn't have to have as much on hand inside of the warehouses. The stock accuracy increased by 10%, which means 10% of the time, 10% more of the time, they did not have out-of-stock moments where someone wanted to buy something and it wasn't in a store. And they greatly improved their picking and shipping for in-store replenished web orders. They slashed the overtime and labor costs for their 40,000 employees, and we're not allowed to say how much. Let's see, let's move on quick. They had an improvement. Fitting room times nearly doubled for their consumers, and they had an additional 6% of associated purchase rate improvements. So 6% more of the time people bought the things that were promoted to them based on this, and they were able to see that improvement in sales. 6%, it's quite incredible. So we'll zip through this because I'm going to be eating into Art's time here in a moment. We talked about those. We won't go to this. Patrizia Pepe is a fashion brand that's managed by Tesselform Spa. They're in Europe, they're in the Middle East, they're in Asia. It's really a network of spas, and they have a floating retail sales department that always has clothes available for people that are visiting the spa to purchase those products. And they had a lot of problems with doing that, so ID came in to supply them with RFID to solve a lot of their distribution problems. It was about keeping up with the pace of fast fashion. They doubled their logistical efficiency. I don't really know exactly what that was measured against, but that's quite a lot. Faster handling for incoming goods because the Labor costs were felt by the spas that were there, not the retailer that was providing not the manufacturer of the products, Patrizia. An accurate delivery to all the stores, which I guess was a problem they had. Undies is another one. I think I've shown some of you this before. So they're based in France. They sell swimwear, sports apparel, and lingerie, and they're known as the digital savvy millennials shopping supplier. They had a problem where they weren't able to acquire all of the real estate that they need to expand into 180 stores in the regions that they needed to sell. So they were able to build in storefronts that are very flat and very thin, and then for these digital savvy millennials, pneumatic tubes to deliver the products to them when they want them. And then the back of the store is located somewhere else in an interior of one of the buildings that they're in, so that they can use very low-cost storage space that is not frontage, retail frontage, and this interaction where a consumer walks in the store, their phone is tracked, it's known what the products are that they're interested in, those products are loaded into those tubes, sent down so that they can try them on or see them, see what they're going to buy, and do it in a very, very efficient way, in a way that their consumers choose to shop. Now, if you look at this is a statement from their version of a CEO. RFID makes it possible to provide their shopping experience that their consumers like. Anyway, RAIN RFID from Impinj completes the link between the digital world and the physical store. And that's what a lot of these location technologies that we're talking about are for, to link up what's in the digital world with the physical store, because the physical store is definitely not dead. Company plug back to me. My company makes printers. We love printers. We make them very, very well. We have an option that can be installed into a printer that programs RFID tags as they go through. So print and RFID programming can both be done at the same time. This isn't to compete with manufacturing of RFID systems that are in a warehouse, but it's to augment at the last mile in a retail environment to solve problems when those tags are wrong, when they're missing, when they need to be updated. And this is the basic way that it works. We have an RFID programmer that sits in a paper tray. Paper that goes into the regular printer just slides right up from a media tray. Paper that has RFID tags on them slides past the antenna, and the programming occurs as a result of what's in the document. And all of this comes back to nobody actually wants to track location. Nobody wants to do one thing or the other, but it's really about why do consumers come into a store, and how do we augment what it is that's going on there to understand what they're doing, whether the store is laid out properly, if the products are in the right place, help them find them. And that really always comes back to promotions. So attention-grabbing promotions. When we look at a picture like this, most of the people focus right on that middle part about the potatoes. The potatoes are super interesting, and those are good potatoes. We need to buy them. That's exactly where people look when they're measured, right straight at that one promotion. So location of the products in the store needs to be perfect to the way that it was planned. If you look at another, where that display gets installed inside of a store, if it's in front of products that you want to sell, then it's going to block them. If it's taking away attention from other products that need to be paired with it, that's a problem. Where do people usually look? They look right there at that display most of the time. For some reason, they look across the hall from it too. If we look at facings maintenance, so this is where location comes back in for fixing facings inside of the store. It's enough for one person to just go make sure that all the facings are faced properly of the products, that they're displayed properly, but it's another to have verification of that, or measurement of how well a store is placed. If we look at that and you're going to try to find golden grams, it takes forever to find golden grams, and that it's a great big mess. People take, on average, about 8 seconds to find them, and they look at 20 different places before they find their golden grams. Now we will lay it out properly, and people look at 16 places, but it takes them about half as long to find the golden grams, and they look primarily at the products that look like golden grams. The, what are those? Bran flakes, crusted crunch. So, the way that we figure these types of things out, other folks do it too, is building an environment where we can test it. Now, a funny quick story about this, you see those potato chip bags on the side. one of the things we did to try to get people to be interested to work on the robotics in the company was we started working with drones in here. And so one of the times we had a converted Phantom 3, DJI Phantom 3 with software running on it that we wrote. And as it was flying down the shelf scanning the products, which is something you're never going to see in a retail store, but it's fun to do, it got a little bit close to those potato chip bags, and the wind from the propellers pulled the potato chip bag out, and then it hit the bag, and it flew into the shelf, and it started flying down the shelf, and there were about 50 potato chip bags all exploded in potato chips everywhere, but it was a lot of fun. This is what you want to not have in a back room at a retailer. And in this case, this is partially my fault. This is the back room of our test store, and it's an ugly way to have things. So let's see. What have we learned today? We have learned that people love Lexmark printers. We have also learned that I offer an RFID option for the printers, and people love that as well. What have we really learned? We've learned that there's tremendous opportunity for location. The uses of it. We've learned the types of location, separating them across to the, what the impact is on the business. Infrastructure impact, accuracy, vendors to watch, examples of successes from Impinj. And we have also learned the value of finding where to click the button, of creating, maintaining, and relying upon the retail technology standards that are made here at OMG, carried over from ours. Thank you very much.
Thank you, Andy. All right, next step, we get to talk robots with Shish. Business strategy, retail industry at Microsoft. Shish, welcome to the podium. If we can welcome him.